This episode of the Disruption Lab is taped in front of a live studio audience. Guys, I want to jump straight in and start at the ground level, no pun intended, start at the ground level on this one, but help me understand, what are critical materials and why are they suddenly, it seems like, getting so much attention?
So I think I'll start with, you need to start with critical minerals before you get to the critical materials. And so the federal government published a list in 2022. Originally it was 54 critical minerals that essentially these are minerals that they've been deemed important for economic or national security. Now it's up to 60 critical minerals themselves, and then the critical materials are made from those minerals. So it's whether it is a high purity metal powder, whether it is cathodes or anodes that go into a battery, those are some examples of what those critical materials are. And if you've ever seen the brain behind this, Tony Crusoe, speak, he talks about these critical goods, which are your airplanes, your MRIs, and so on. And they're made of critical components. They may be permanent magnets, it may be the turbine blades on the jet engines, and the critical materials are the things that make those from critical minerals. And I'll let
And so, last conversation I did have with Tony, we talked about the rare earth minerals that make up some of this list. Can you give me some examples? I think one of the ones we talked about, Jamie, in the last conversation with nickel was a big focus early on for some of the things you guys are working on. So give us some examples of some of these minerals that maybe folks, that are maybe vaguely familiar with the periodic table might recognize.
Yeah, nickel's a big one that we're chasing after. Most of the battery elements are the manganese. Cobalt is another big one. A lot of the rare earths are entering as well. And rare earth doesn't mean that it's rare in the earth. It's just very difficult to get, so it's rare that they're able to be harvested because they're spread out fairly well, opposed to concentrations like you find in nickel.
So let's talk a little bit about that. When you say they're spread out and so on, give me some sense of the global landscape of this space and where do we find these? Where are they concentrated? And not just the supply chain. Who has the upper hand and leverage in some of these things on a global basis?
So I would say when you talk the critical minerals themselves, fairly spread across the globe. You talk cobalt, and most of the batteries we use have cobalt in them. About 70% is in the Democratic Republic of Congo. You talk nickel, most of that's in Indonesia or the Philippines with some spread around. But ultimately, it's who's investing in the companies and who's investing in the mining of that, and that's primarily China. China is the main investor. When you look at the Democratic Republic of Congo, most of the companies are Chinese companies or they're invested. The same with Indonesia, most of them are Chinese companies. Rare earths, they have a large share naturally occurring there. I'm working on another initiative on tungsten right now, and they have about 60% of the tungsten reserves in the ground. And they have the processing of that as the next step. Some of these, about 2/3 of our critical minerals are processed overseas. Some of them are about 100% processed. So when you talk some of the rare earths, that next level processing to get it to a high purity, 100% in some cases in China. So
the landscape has shifted over the last several decades. I understand that the United States used to have a larger role maybe in some of the work that was happening. You hear terms like reshoring, especially as it relates to critical materials. Help me understand, where are we at with that? Where did that come from in terms of the focus and the refocus?
Yeah, probably 40 years ago, maybe 50 years ago, the U.S. made a concerted effort and said, we want to focus on the high value manufacturing, and that's what we're going to do here. And we're going to leave the lower value, dirtier manufacturing, and we're going to push it over to Asia. Well, that's worked well to the point of economic viability, but the challenge is now we're dependent on that. As Will said, some of these minerals we are almost exclusively reliant on countries like China to produce those. So regardless of where nickel is pulled out of the ground, 95% of it is processed in China or China-controlled areas. So even if Australia has some, even if other friendly countries have it, we cannot process it today. So the idea of onshoring or reshoring some of those technologies is really bringing that manufacturing, that refining back to the United States.
And when it comes to why some of this is coming up right now, you look at the South China Sea, about 50% of critical minerals trade travels through the South China Sea. I mentioned Indonesia, I mentioned the Philippines with nickel. All it takes is, and we saw this in the COVID pandemic, is one thing to go wrong in that region, and that's going to shut down all of that trade. And so then where will we get these minerals from? We've become so reliant on one very small region of the world to get this. You go back and you look, the vignette that I like to use during COVID was Kentucky Motor Speedway. You had 70,000 Ford trucks and SUVs. They had to rent the speedway, parked, almost completely manufactured, minus one microchip. They needed one chip, and they could not move those and sell them until they got that one microchip. And that shows how fragile the supply chain is in itself. Now, let's go and look at, things with Taiwan, global tensions, tariffs with China, and it creates a whole new layer of concern. And this is bipartisan, right? So the previous administration was focused on this. The original Critical Minerals Task Force started under the first Trump administration. So this has continued to ramp up. I think COVID showed us that supply chain fragility.
Give us some examples, so you mentioned some of the maybe critical materials or maybe even the downstream even further in some of the things that we might understand. But as this challenge continues to elevate, what are some of the other industries? What are some of the other opportunities that I think people would understand if it's not national security, economic impact, and some of the other things maybe that you could highlight?
Yeah, we spent a lot of time, we've talked about nickel quite a bit, but just in the nickel arena itself, so batteries, any type of lithium-ion battery, the newer technologies are using some different chemistries, but the main chemistry used in the United States is nickel-based. You get into metal injection molding, 3D printing, all nickel coating, so any type of electroplating, electroless nickel that goes on any type of plating is high purity nickel. It's used for catalysts. It's in high. I think Liv talked about it that the F-35 uses a significant amount of high purity superalloys. With this, so high purity steels. There's lots of different areas. Pretty much a lot of MRIs. Obviously, we talked about some of the medical stuff in the magnet side. So a lot of the things that you deal with every day use this. There's certain types of supercaps that use it. So we get into electronics. A number of our partners are working in the semiconductor area as well. So pretty much most things you touch will have some type of critical mineral in it.
So I want to shift the line of the discussion a little bit and talk about specifically Critical Materials Crossroads, like the organization and the focus in this region on this topic. So tell us the origin story of CMC. Why did it start? How did it start? Kind of what's the mission?
So CMC started out of the Chips and Science Act. We realized that there were some vulnerabilities around microchips, around pharmaceuticals. This is the nation realized this, and around critical materials. And so applied for a National Science Foundation grant to develop towards an Engines Award, which we'll probably talk about some later. And we kind of stepped back. We said, what is this region good at? You look at the history of Kansas and Missouri and this Kansas City region. There are 7 battery manufacturers on the north-south border of Kansas and Missouri. There's 13 different facilities that manufacture batteries. We have the hydrometallurgy and the metallurgy experience and the mining in southeast Missouri. And they mentioned lead-acid batteries. There was a complete circular economy on the lead-acid batteries here in Missouri. And so we knew how to pull this out of the ground, we knew how to process it, and we knew how to make some of these critical components that would go into submarines or go into your automobile. And so we have this history of that. And then on top of that, when you talk the crossroads, we're right in the middle of the country. And we have a maritime highway with the Missouri River. We have the number 2 largest rail yard by size, number 1 by cargo capacity, that actually flows through the rail yard in the country. and St. Louis is number 3. So we have this dense rail network. We have this, all these natural assets in the ground. We have this industrial history on how to do it. We have, when you talk about Panasonic and the DeSoto plant, they specifically came to this area because the advanced manufacturing workforce base within the region. And so there's all these pieces that fit nicely together around the critical materials. And so as we looked at that, we said, this is what this region is good at. This is our specialty. And that's how we went that direction.
Is that, I mean?
Was and is. I mean, we still manufacture the components. You look at Missouri S&T with their mining and their metallurgy degrees and experience. You have separately the EDA Tech Hub. It's the CM2AE Tech Hub that's focused on test beds for hydrometallurgy. And then we just shut down the last smelter in 2014. I want to say it was 2014. It was the Herculaneum lead smelter. And so we have offshored it, but we still have the knowledge and we still have the upstream and the downstream, just not the midstream, which is where we're focused.
Yeah, so talk to me a little bit then about so spoke a little bit about why. What is the mission of CMC specifically? Like, what is the goal of the organization and the convening of partners in this ecosystem? What's the organization focused on?
Yeah, really our goal is to bring together the partners that are needed to create an ecosystem, a critical material refining ecosystem in this area. So our job is really to bring partners together, to introduce funding to entrepreneurs, to introduce offtake customers to suppliers, to bring in workforce partners. And really, we are acting as kind of the hub of connecting all these dots, where eventually it becomes a self-fulfilling ecosystem. If we are very successful, in 10 years, we won't exist because this will be this major network that's running without us, this ecosystem that churns, that has all these connections that we've just helped to facilitate. So at this point, we're using all of our leverage, a lot of, it's very interesting when you work for UMKC. A lot of people will take your calls. If I come from the business world, if I would call all these people, they would have never taken my call. But if I call from the university, I'm very non-threatening, and I'm always offering something to them. And so we were able to make a lot of connections. I think we'll talk about it a little bit later, but we have over 230 partners signed up to be part of the CMC group, is really facilitating this ecosystem.
So what does that collaboration look like? Like, who's at the table now as you guys are kicking that off and getting that off the ground, or have been doing this work for a while? I shouldn't say starting. And then who's not at the table that needs to be?
So I'll start with, when you look at it, we've broken down into categories. So we have government partners, we have workforce partners, we have industry partners, national labs, universities and other research institutions, entrepreneurs, commercialization, so capital as well. So it's this diverse array of partners. When you say who hasn't come to the table, I think we've done a good job with everybody in the region, and you could say everyone from the Kansas City Civic Council is involved to all the universities in the region are involved. One of the things about doing a grant, we were working towards the National Science Foundation Engines grant. There were also 2 in Kansas, and there were 3 other ones that were competing towards that in Missouri. We were the only finalist who moved forward out of the last 15 teams. I think we were the only semifinalist as well. And so, obviously there were some competing interests in maybe some government institutions. So, there's more work that we need to do potentially with some of the government institutions within the Kansas and Missouri region.
I'm always, our charter here is really how do we become a convening force? I mean, I'm continually fascinated by the region's need to establish a label on what we're good at. And it's difficult when you look, we have 16 industries that are all kind of fighting for a place at the table, and they all deserve a place at the table. And I keep saying, like, our specialty isn't any one sector. We shouldn't double down on any one sector. Because we have this amazing convergence opportunity, this amazing intersectionality that's defined this region since its beginning, and let's double down on that. All that said, I was telling Tony on the last conversation, if there's one where you think we could establish a leadership, like true national leadership role or a top 5 role in a specific segment or industry, this is the one. And it's based on a lot of that history that you were talking about, and a lot of the convening of those, whether it's transportation and logistics, whether it is the manufacturing side, it's bringing together industries horizontally across to really kind of build this ecosystem that you guys are talking about. So I want to transition now into that, like that NSF engines conversation that you just referenced, that grant, that opportunity, and the fact that you guys have been able to proceed down the path on that and make it pretty far, and pending news.
Hopefully,
I
really
think we're
far.
all edge of our seat waiting to hear that. So tell me, what is NSF engines? What is that grant opportunity, and where's that stand right now?
I can start with what it is.
Perfect.
So when you look at what the Critical Materials Crossroads is, it's trying to replicate the place-based innovation that you see out of Silicon Valley or medical devices in Minnesota, right? And so it's almost this self-fulfilling ecosystem where all these conveners come together and they continue to innovate and continue to innovate. They continue to be the thought leader and develop new technology. And so a huge piece of the National Science Foundation is the innovation that we need to do to actually decouple from foreign entities of concern. It's focused on economic development as well. So there's a whole nother component of bringing economic development to the region. And so places that have not had an innovation ecosystem boom but have all the elements to do it and all the pieces are put together, that's sort of the basis of the program.
Yeah, so they really have 3 major pillars that they like to talk about. So research and development, like big focus is National Science Foundation, big focus on research, obviously. Innovation and commercialization. So basically they want to see you take that research and translate, they call it translation of innovation. They want to see you translate it to commercialized solutions. They don't just want to see professors pumping out ideas and then not going anywhere. So that's a big portion of what they want to see and what they want to help fund. And then the workforce. They're big on having a developed workforce and using the funds that they're contributing to help develop the localized workforce. And then surrounding those, they've got some other contributors like stakeholder engagement, and which is really engaging with the community, and government engagement, and then the funding source of it, which is a big portion of what they're looking at. But they want to fund research, innovation, and workforce. They don't want to put buildings in the ground. They don't want to buy land. They want to pay for the development of technology.
So I want to, I think we all get research. I think one of the things the regions, kind of struggled with over time is the commercialization of that research. Or even if it gets commercialized, oftentimes it doesn't get commercialized in this region. We don't capture the benefits of the research that happens. This is one of those opportunities, again, where you get to capture the economic output of that. Describe to the group, like, what is the downstream one? I think we talked about critical minerals, critical materials. Explain this idea of downstream 1, downstream 2. Like, how does this go down into new venture creation, into commercialization opportunities? How does this start to look from an innovation perspective if you're successful in 10 years?
Yeah, so a big part of our proposal was focused on the research innovation side, but to enable that, the NSF engine fund is not paying for this, but we're looking at standing up an industrial business park that's focused on refining and really focused on that co-location capabilities, what that offers. Being this region, as Will spoke about, having river transit is a big deal. When you go from truck to train, you save order of magnitude, and when you go from train to river, you save another order of magnitude. So when you're shipping thousands of tons of this stuff a year, it makes a big difference having access to barge transportation. And so co-location in an industrial area helps enable some of those developments. And really we're focusing on having warehousing and other areas to support those refiners to come to this area. And to your point about going in different areas, especially in the refining area, the benchtop you can do an affordable cost, but when you move to pilot and demo, this is an extremely CapEx industry. CapEx heavy. So it's not like a software startup where you have a guy in his pizza box in his mom's basement, right? That's not what we deal with. A demonstration or a pilot facility is going to cost you $10 million. A demonstration facility is $50 million. And then when you go to production, you're in the $100 to $500 million for the equipment and infrastructure. And each time you're going from pilot, each phase, you're losing what you invested previously. So one of the things that we are trying to do is make that pain a little bit less by doing some shared spaces, much like this, where they can share facilities, share equipment to make this CapEx heavy situation much more attainable here in Kansas City.
And having been, I'll just characterize it this way, just to be succinct. Having been good at this in the past and maybe lost the edge and the opportunity, and now being able to revisit that history and come back and get a chance to be the leader, a leader in it again. There have been advances in things like artificial, like other technologies that could maybe improve the efficiency and efficacy of some of these efforts that you're talking about, and maybe clean tech or some of the other. Is CMC looking at those elements, and what does that mean when you bring this back?
I'd say advanced manufacturing is a huge piece, and advanced manufacturing, all of this is about reducing that cost, because ultimately.
That's why we lost it in the first place, right?
It is. Yeah. If you look at some of someone spoke earlier about the government involvement. You look at the Department of War recently. The Department of War has focused on directly investing in companies within the critical mineral space. It was $1.6 billion directly invested in. Do you remember? It was somewhat related to the Project Vault that came out last week. MP Materials with rare earths, $400 million. So there's a piece of that with the government, but there's another piece to get that cost down, you have to build in more efficiencies. And that's where the advanced manufacturing, AI, all of that is part of the thought for the direction that we have to go. So, we mentioned the research and development. Some of that it's all use-inspired research and development. And how can we take that and make it practical to buy down that?
I'm a huge basketball fan. I won't tell you necessarily who I root for, Rock Chalk, but I cringe every time I'm watching a basketball game and the announcer says, "This guy hasn't missed a free. He's made his last 20 free throws," and I'm like, "I bet he misses the next one." So what I'm about to say, I just want to put that lens on it.
Don't say it.
Oh, I have to. It's on my list. We don't get the grant. We don't get the NSF Engine grant. What does success look like for the organization and for the region? If that actually materializes that way?
If you had asked me a year ago, I would have said we're all looking for jobs, but
what's changed? Yeah,
it's taken on kind of a mind of its own. Where it used to be three of us and Tony Caruso kind of pounding away at this. Now we have civic council members that are driving activities completely outside of what we're doing. So this is kind of taken off, and a lot of the partners are here today kind of coming out to support this. It's become much more than a university-sponsored project and much more of a real event we have a meeting on Friday that's talking about the industrial business park that's nothing to do with the university. It's all about developing this thing outside of this NSF engine and stuff like that. So a lot of our activities are now sustaining themselves outside of a university or NSF funding.
The last conversation that Jamie, you and I were a part of, I asked the question to Tony, there are a lot of headwinds when you're trying to look at something that transformative and something that aspirational in a region like this. And I say that I've been in Kansas City for 35 years. But there is something about this region that, they call it the show me state for a reason. And so what does a starting point look like that can be a trigger or a catalyst? And how does that early innovation look like before you start to maybe move forward with a multi-billion-dollar campus and some of the, investment in the ground? What do those early wins look like?
I don't necessarily know if there's a single thing. It's across the spectrum, right? So we have partners that are at a very low, what they call technology readiness level, TRL, and very low manufacturing readiness level. And then we have people at the next scale. So from bench scale to lab scale to pilot to demo to full scale. And so it's getting multiple of these partners in place. You get the first one and the dominoes start to fall. And I mean, I think it's moving in that direction. Everyone from the Area Development Council, Economic Development Council, from Missouri DED, everyone's involved in the incentives to bring partners here. We have members of Congress involved. Senator Schmidt's office has been great. They've been very, very involved in what we're doing. So all the way up to the governor. And so I don't think there's a single trigger or single catalyst. I think it's multiple small pieces that fall into place that help this grow.
Yeah, I think we talked about quite a bit of the potential catalyst. The NSF engine is really the catalyst that can get this going, and that's what we're hoping for. It's a $160 million grant, but if you look at the size of this project, it's not substantial. The project is targeted to be $3 to $4 billion over the next 10 to 15 years, and so 160 million is a lot, but in relation to that, it really, no one wants to put the first dollar in, but once that first dollar in, a lot of people become very interested.
Oh man, we always equate these things to being at a pool party, right? You ever been to the pool party and you're just waiting for the first person to get in? Nobody wants to get in. I think this is this. I've lived it for 10 years doing this project. I feel the pain. Let's shift. So startups, the innovation, some of the things that you guys have talked about. You can see who the players are, understand what that looks like. Talk to me a little bit about the role the universities and the national labs have in kind of creating this like globally competitive ecosystem here in the region.
So I would say when it comes to the universities, each university in the region has a specialty that is very complementary to different parts. You talked about the AI. You've got Wichita State University with everything with aerospace, advanced testing and simulation. You've got Pitt State with advanced materials. It's more the collection of everyone that we have. And we go so as far as the Colorado School of Mines. I believe it's Michigan. We have this collection of partners that each have a piece of the puzzle that work together. When it comes to the national labs and their contribution, some of the cutting edge research that's taking projects up to a technology readiness level 3 or 4 takes place. One of the relationships we have is with Ames National Lab. They have the Critical Materials Innovation Hub. The CMI Hub is focused on everything with critical materials up to that transition point for a technology to start actually looking at the commercialization. And so each one of those has a unique piece that they bring to it. And I would have to go down each university and talk about what they contribute, but each one brings a different piece to it.
When we talk about place-based innovation, you've got this conversation about density, this conversation about proximity, needing to be measured in feet and not miles to really become a center of gravity that it's meaningful. And we've seen it in other cities around the world and so on. If each of you were to say, all right, if this partner, this global partner, this national partner decides to plant a flag in this work in this region, because we talk about the assets that are already here and how do you get them together, and that's one part of the conversation. But when you become the center of gravity and you have folks that are well outside this region thinking that they need to be here, who are those ideal targets and who are the ones that maybe aspirationally are like, if they're in, we've made it? Come on.
Well, we talked quite.
I know you've all got them. I know you have.
We talked quite a bit about Panasonic and really having their supply chain, doing some of that refining here, right? So that's currently done overseas. But we talked to Panasonic again. We come into it as a university, so we can ask very probing questions. And I think they divulge a lot of information to us that it's harder for them to talk to some of, a supply chain guy that's trying to sell them something. We're just trying to learn, and they asked us 3 questions, and the second question, first question is, I guess their initiative was, how do we get domestic supply? And the second one is, how are they going to handle their waste stream? And how is their supplier going to handle the waste stream? And how is their supplier going to handle the waste stream? So those are challenges that they are seeing, that they're facing, that they're very conscious of. But having somebody like that size, just because they're local already, bringing in some of their supply chain, we find that with other industries here in Kansas City, Ford did that quite a bit when the Ford Tacoma plant went in. They're bringing in muffler manufacturers, they're bringing other suppliers to this area. Something like that is pretty powerful.
And Panasonic has now publicly stated that they want to bring as much of the supply chain as local to the Kansas City region as possible. And so, you have some in Clarksville, Tennessee, outside of Fort Campbell, Kentucky. LG Chem is standing up a cathode active material facility. All they're doing is taking what's called a precursor cathode active material and turning it into the cathode active materials. So all they're doing is really adding the lithium to the precursors. And so that's not what Panasonic wants to do. They want to take as much of that supply chain as they can and do it here. And so they've expressed the interest, they've done it publicly, and now it's up to us to find how we can overcome those challenges.
You listed out the 3 pillars: the research, the innovation. We've spent a lot of time in that innovation and building an ecosystem around that commercialization. I want to go to the 3rd pillar that you mentioned, was workforce. And that is always, that seems to always be one of those hurdles that when we talk about bringing industry, we talk about bringing, major segments to the region where, the most concern starts to come up. Where are we at in the workforce? What needs to happen? What kind of workforce are we talking about that needs to support an ecosystem like this?
Yeah, so our workforce expert decided to bail on us, so he's not here. So anything we say, it cannot be taken, or should be taken with a grain of salt, because
We will hold Tony Weiss accountable to that, for
yes,
sure.
yes.
For
So
sure.
that is his fault. Very much, we are looking to develop the workforce for an automated and manufacturing profession, but not necessarily for refining. So it's really making it, it's not just a refining technology that we want. It's a lot of automation, AI, a lot of creating certifications, and these are buzzwords that he throws around a lot, so if I get them wrong. Certifications, allowing them to be upskilled and have paths to grow within the career. So a lot of trade schools, a lot of starting all the way at the K through 12 areas. We've partnered with all of the local school districts around the area about how do we get more STEM and more development in their area, get them excited about doing it at the community college level for the 2-year programs, pushing it into the college areas where UMKC has decided to, I think they officially announced that we're going to be bringing in a new Center of Excellence, or a new degree program focused on chemical engineering, and then really having a scalable process throughout the entire program that is driven by the community and the people that know it well. It's not driven by UMKC. There's lots of partners that are experts in that we are bringing together to make that happen.
What do you guys think is the thing that's most misunderstood that you would want people to maybe, if you could, the thing you've heard that you wish you could just turn the public's opinion on, or that maybe has been misrepresented about the work that you guys do?
I have one. So what we're doing is we're not creating mines. We're not planning on building a bunch of mines or digging a bunch of mines in Missouri. We are basically taking that ore that's been concentrated and then doing the processing to the next step. So a lot of people walk away saying, we don't want mines in our backyards. We don't want to do this in Missouri. It's really about refining the minerals that we're pulling in from somewhere else. That's a question we get asked quite a bit.
And I think when people hear refining, they think of the old process. It's pyrometallurgy, and I'm not a metallurgist. Where you cook, where you heat the material up to a certain temperature, right? Some of the newer processes are much cleaner, and that's one of the focus areas is clean processes. People hear refining and they think dirty. We talk refining, we talk some of this advanced manufacturing, and we talk about how we want to reduce the energy. We want to reduce the water, or some of the processes are completely dry and use no water. And then also ensuring that the community understands, we're learning the lessons of the past so that we keep what we're doing clean.
So, you talk about the clean tech, the clean opportunities there. One of the areas, or I think the area that you guys are kind of concentrated on, is that Blue River Valley. That old, there was old manufacturing facilities, and that was a concentration of stuff over there. And I could see, the concern about some of those types of things. What has happened? Give me some examples of some things that have happened that have changed that narrative and changed that story, where folks maybe shouldn't have that concern. I think you were starting to kind of reference some of those things, but what's changed?
I mean, I think one thing that's changed is that we're transparent. I mean, we come to the partners, it's the same that Jamie mentioned with the way that businesses will talk to us as part of the university. We're transparent with what we're doing. So I think when you talk, and we go down to the lowest level, we go down to the local level, and we'll start at the local level and then work our way up. Instead of forcing this on a community, we want the community to understand what are the community benefits. How are you going to source the jobs when we develop this here? How are we going to do this in a manner that you see that we're being stewards of your resources, stewards of your land, stewards of your watershed? And so starting at that local level and being completely transparent with the processes that we'll bring in, the partners that we want to bring in, and what is our risk mitigation plan? What are the things that we plan to do to actually improve your region? So
Yeah, I think one of the great things about the university taking the lead on this is that it's not a money-making venture for us. We're not going to be making the refining. We're not staying at these massive buildings. Our job is to really to create, we work for the Office of Strategic Initiative, which is focused on economic development in the area, really bringing a change to the community. And so there's no way we could do that at the same time be polluting the rivers or causing lots of distress. And so the initiative being led by a university really has some pros in that regard. There's challenges in other ways, but that one is really allows us to be, to Will's point, very transparent about what's going on. A lot of the technologies we are going after, we've met with Missouri DNR, who will be the oversight for environmental standards, and everything that we will do will meet or exceed their minimum requirements. So it's very upfront that we have a minimum standard that we're going to meet, that we're not bringing something on here just for a monetary gain at the expense of the environment and people around it.
All right, so I want to play back my "you're going to miss the free throw" analogy and say you guys are going to make the free throw. So you make the free throw. What do the next 3 to 5 years look like? What's that unlock? And then what do the next 3 to 5 years look like when you guys get awarded this National Science Foundation Engines grant?
We start with a very, very large steak dinner that we'll be going out that we have told our professor that he...
It won't be the grant money that pays for the steak dinner. Someone in this room will probably pay for that.
Yes, somebody will pay for that. Go ahead.
yeah, I think we're already working through our plans for how we piece all this together. This is after the current proposal I'm working on. My next step is laying the foundation for the systems that will actually govern the Critical Materials Crossroads as it grows. And I think then, we get that award. Those steps is to aggressively pursue the research and development and the translation that will kick this off while we build out that workforce program to meet those needs. I think, we're still doing it.
What are the parameters of that grant award? What does it actually? You talked about it's not bricks and mortar. It's not some of those other things. What does the scope of that grant actually?
So we provide a budget for them on how we want to spend it. Each program or proposal is able to do it differently. I think we ended up with about 40% of it in research, 50% in research, another 30%, 35% innovation, the balance in workforce. Well, and there was 5 to 10% in governance and oversight, but 20%, 15% in workforce. How the grant works is you're awarded the first 2 years, and then they do a review process. So we get, it'd be $7.5 million per year. Years 3 through 5 is $15 million per year, and then there's another gate process, and then the last 5 years is $20 million per year. So we have to be successful as we're driving through this. We can't win the award and then in 10 years come back and say, hey, this didn't quite work. Once we get the award, we start on the clock to make sure we're successful for that year 2 evaluation.
And that physical placemaking element that's not included in that grant, this becomes catalytic for that in many of the ways that we talked about earlier. But what's that start? I think the conversation that we were having about what's spec build, what's build to suit, who's interested, and where do you go next with that physical plant piece? Where does that start? How does that get started?
So that start outside that's a lot of what I spend my time doing when Will does all the smart proposal work. I'm working on a lot more the site alignment and working with that industrial park side. So we have a number of partners on the development side and on the land side, the municipality side, to put together the best program, best location for that. So again, that is not part of the NSF funding. So we're kind of running that outside of that. There's lots of, we've probably spent, we actually started at a different site, but we've moved over to the sites that we're looking at now. We've been last year and a half on them, really digging into it, doing a lot of research, doing a lot of engagement to make sure this is the right site for us. And so at this point, we are pretty close to making decisions on final sites and actually starting to put schedules together about when we will put the shovel in the ground.
Jamie, I want to go back to your hot button for what you wish people would understand, or the misconceptions that maybe people have some about the work. And you had mentioned we're not going to be digging mines, we're not going to be doing a lot of that kind of work. We were trying to be intentional tonight. We're trying to do this more and more in 26. Obviously, critical materials, the critical minerals, the work that you guys are doing, and to be able to take raw materials and transition those. But we were intentional about the first panel tonight. Talk to me a little bit from your perspective about the opportunity around things that already exist that become source materials for this work that don't require some of that, some of the mining work and that conversion of raw to produce material.
In the refining field, there's a little bit of difference between recycled and raw ore, but we don't really care. I think Tony was asked what percentage he thinks in the 10 years what will be recycled versus raw, what's called primary stock versus secondary. And the goal is kind of 50-50. So it is very much a plug into the recyclers and figure out how we can reutilize this material that we have available to us.
And is that one of those benefits that regionally, when you think about the access to the region and the ability to bring materials into the region, that this becomes, kind of wow, I can't believe I'm about to say this out. The dumping ground for everybody's else waste becomes, the gold that we have here to be able to power the region?
Yeah, so as Liz said earlier, most of it shipped overseas, right? So if we can capture some of that and have it has to be an economical process. They're not going to stop shipping it to China if it costs 10 times as much to do it here. So we have a number of research projects that are focused on that side of it, is how do we do it economically to make the viable solution here in Missouri.
And I've been on work with Diana. We've talked about this a lot. We've talked about the legislation piece. We've talked, I did some case studies on places where it's been successful, New York State, specifically putting it on the producers. That's what New York State's done to go on. The average, when you talk e-waste recycling rate, is 18% in the U.S. New York's up to about 40 to 50% on their e-waste recycling. So you talk about recapturing that instead of it just going into a landfill. I think that's an important piece of our critical materials supply chain because we don't have the ore in the United States. Even some of the minerals we don't have in Canada or Mexico. And so there's going to be a point where if there are, something that creates supply chain disruptions, if we have in place a healthy and robust recycling, e-waste, scrap, you name it, then that's a much more resilient system. So
last question for you guys. When we talk about what can the ecosystem, what can the audience tonight or the people in the region, what can they do? Or how do they participate or how do they help, in the efforts that you guys are doing here?
I think we've talked to most of you at some point or another, but continue to talk to other people and help form the partnerships. It still, for the most part, it's three of us that are doing most of the day-to-day, the outreach, the work, and that's growing, by the way. That is growing, so I'll put out a plug that it is growing right now. But at the same time, continue to push. If you have a congressperson that you want to talk to about legislation or about getting their time invested in this ecosystem, not just federal, state, talk to your state legislature about the things that they can do to help promote economic development for Kansas City and for the region. I think all of those would be very important. But I think we've talked to most of you that are in this room, somebody in our team, so.
But it's certainly, I mean, we are taping this, and so this is going to go out to a broader audience, but driving that awareness with your, local, state, and federal officials that this is important and this is something, don't believe all the hype, the negative stuff. Like, this is something that's good for the region, something we need to get behind. So.
I think, everything is important, right? Everybody says their thing is important.
Sure.
But I think this is one of those subject areas that touches on everything that we do every day. You've gotten used to getting on an airplane and flying somewhere. If we don't have nickel, that's not going to happen, right? If we don't have rare earths, you're not going to be able to get that MRI that's going to diagnose cancer, right? So, this is something that affects all of us. It affects the entire supply chain. So, when we talk about putting additional emphasis on it, there's a lot at the federal level. There's some more happening at the state level. I think we could do more, so.
I agree.
Well said, well said. Anybody who knows our story here at Keystone knows I'm a big fan of small teams that are trying to do big things. So I appreciate the fact that there's 3 of you, soon to be more, it sounds like, doing some amazing work for the region. Thank you, for pushing this forward. This is definitely important. And like I said earlier, this is absolutely one of those areas where Kansas City, the region, can be a national leader and talked about in kind of rare air categories in terms of where the actual work is happening in the United States. So I appreciate that you guys are kind of pushing that forward. And we wanted to set this up tonight as maybe kind of an ongoing series of conversations around this ecosystem. So there's a reason we started out with like a baseline of what is it, doing some education, but I think there's going to be some downstream things that we'll talk about over time. There'll be some progress you guys are making and doing that I think will really need to be highlighted in the community and part of what the innovation community, the entrepreneurial community, the workforce development community, all the things that we represent. So thank you guys for spending some time with us this evening. We'll give Tony some crap for not making it. It sounds like he's doing something important though, so appreciate that. But again, thanks guys, appreciate your time and look forward to having you guys back. And I can't wait. I will maybe contribute to that steak dinner when you guys get that grant because it's an important step for all of us. So thanks again, appreciate it. Give me a hand, everybody.